हेलो पेना मैम।
हेलो।
यस मैम, आवाज आ रही है सही से? मैम आपका माइक्रोफोन ऑन कर दो, आप म्यूट रखा है, अनम्यूट कर दो। यस
मैम आप स्क्रीन प्रेजेंट कर सकते हो, फर्स्ट स्लाइड।
I've already shared my screen, but it's not visible, I think.
Yes ma'am, and live recording start within half a minute.
Is my screen visible?
No ma'am.
I've already shared. Just a minute.
Okay ma'am. Yes ma'am.
Good afternoon, all of you. As we believe nothing can stop us to learn, so that we all are gathered here on virtual media. Hereby, I welcome you all in today's session about 5G network architecture and SDN. So, without delay, I would like to introduce our today's speaker, Dr. Upena Dalal, ma'am, on behalf of Parul Polytechnic Institute, Parul University. Welcome, ma'am. To
Thank
give a
you.
quick introduction about Madam, she is a professor at SPNIT University, Surat, and her area of research is 5G technology, wireless communication, fiber optic, and image processing. Now, Madam will continue. Over to you, ma'am.
Thank you so much. I think I'm audible.
Yes ma'am.
Okay.
Yeah.
You can go
So,
on.
good afternoon, everybody. Let us start with the webinar directly. Before that, I would like to thank Parul Polytechnic Institute and Parul University for inviting me for this webinar on fifth generation network architecture and software defined networking. I hope many of you might be having the background of communication and networking part. For those who are not having this basic knowledge, I will go with some introductory slides so that they can understand the fundamental requirements, and thereafter they can uh, opt for this particular topic very easily. So in general, when we deal with any network, there will be a big question that what type of networks we are dealing with. What is a network? Network is nothing but a system in which there is a resource sharing. There are three types of networks basically identified. Infrastructure based networks, mostly the cellular networks on big scale, for which the deployment is already made on the area like a city, or maybe it's all over the world, connected to each other by using the mobile towers and the supporting hardware. Other type of network is ad hoc. They may be with cellular support, but mostly the ad hoc networks are working on the unlicensed range of frequencies. Infrastructure based networks are working on the licensed frequencies, for which we have to pay the bills. Ad hoc networks, we need not to pay anything, but sometimes like local area network or some small scale deployment, we can apply the cellular concepts for the coverage area and other things. Third type of networks are broadcast networks, in which we again in broadcast we have two types. We have the analog broadcast systems like FM, which is tuning based, and the commercial frequencies are already owned by the broadcaster. And the other type of broadcasting is the digital video broadcasting, which is again done by the service providers, for which we have to pay. So this is actually the preface or the initial understanding about the various types of networks which coexist in the recent scenario, and they have their own applications and the requirements. Now, when we study any particular network or any system, it may have its own electronics aspects and it may have its own software aspects like the computing and real-time calculations, applications, and so on. So, as far as the networking terms or the networking terminologies are concerned, electronics part will form the basis for physical and data link layer, while the software aspects will form the basis for the higher layers. This I am talking in terms of OSI reference model. All of you might be aware with the OSI reference model, which is actually the model which gives you the various issues to be dealt with when you design a particular network. How to control the physical layer, means the physical connectivity or the topologies or the synchronization among the devices or many more issues we have to deal with, the packet transmissions, routing, flow control, their end-to-end delivery, everything. So for the various tasks among the networks, we should have certain rules and regulations, and they are called the protocols of the network. And these protocols are designed or rather defined on the basis of OSI reference model requirement. So as far as the OSI model is concerned, the electronics part will form the basis for physical and data link layer, and the upper layers are related to the software in most of the cases. Now, as our focus is the 5G architecture, our concern is we have to develop the architectures on the available resources or available infrastructure, or we don't want to throw the old things, and whatever development is there, it is just the additional inclusion in the architecture without throwing the old systems. So if you are not thorough with the first generation, second generation, third generation, fourth generation, fifth generation systems, you can go to any particular reference in which you will have the fundamental comparison among the systems. Let us start with the scenario of 2010, just 10 years before, because two old system cannot be covered in detail over here because of the time constraint. So here the scenario shows that the interworking between the GSM radio access network and ATRAN, Universal Telecommunication Radio Access Network, that is 2G GSM and 3G ATRAN. These two are interworked with the help of base station controller, mobile switching center, the radio network controller RNC, and of course GSM supports the GPRS core also. So this was the infrastructural architecture or the infrastructural scenario which was there somewhere in 2010 when we had the 2G and 3G services available. Now here one thing we can note that in the case of GSM radio access network, the towers are known as base stations, In Atran, the towers are known as Node B. It is just technology which was enhanced with the gradual inclusion of the various uh, network infrastructures. So, here one more thing we can observe that the 2G GSM services are actually, see, these are all the digital communication services. So 2G GSM services were supported with GPRS for packet switch services, and it was already active for the circuit switch scenario. While ATRAN was developed for dedicatedly the data services or the packet switch services. So this was the infrastructure or the architecture available in 2010. Here also you can see the connectivity to the ISDN network and to the internet. So with this fundamental, there was one more parallel development, and that is the development of mobile IP. You know, in GSM scenario, we had the mobility support. Even in 3G UMTS also, we had the mobility support. But few years back, whatever networks were available, they were all IPv4 based, because in most of the networking part, the computer was a desktop and fixed in nature. So whenever the mobility started, beyond the pedestrian mobility, the requirement of new IP addresses started when the data networks are evolved with a very fast rate, and the users also increased. Now you know we have millions and trillions of users, but there was a gradual rise. So people found that there's a requirement of change in the mobile IP, and they started with IPv6 scenario, which is 128-bit address, which was earlier 32-bit address in IPv4. And IPv4 was based on subnetting. So it was the hierarchical IP, while IPv6 is a flat, dedicated IP provided to the user. So individually, without any hierarchy, that person can be logically identified. So apart from the GSM and 3G UMTS scenario, there was a parallel development of the internet management system, which you can see in this particular slide. Also, we have the connectivity to the access router. We have the inclusion of home agent, in which we have the home location register, where the user is registered for the packet switch services, visitor location register, where the user is in the roaming part, and so on. You can go through the detail of home agent, foreign agent, agent discovery protocols, and many more aspects. This is all included in mobile computing. So mobile IP and mobile TCP was a huge revolution to have the faster mobile anywhere, anytime data networks. So, you know, there were two big revolutions. One is the development of IPv6 based networking, and parallelly there was another development, that is the LTE, long-term evolution. Now the infrastructure of the first slide architecture, 2010 architecture, if we combine in this particular scenario, you can put it somewhere over here on the left north portion, like 2G GSM, Age, 3G UMTS, etc. There you can put that particular scenario, and all the surrounding part is the addition. For LTE, you had the separate air interface. Common packet core was provided, which was enhanced packet core for IPv6. Of course, we have not thrown the circuit switch or the packet switch services at all. So, LTE, Internet Management Services, 2G, 3G, all combinedly form the base for 5G scenario. Now, when we say 5G, we have a fear that, oh, this is something amazing, we don't know anything about it. But actually, 5G is not that complicated. Only the thing is, it is made or it is treated in a different way. Earlier, everything was based on the protocols, rules and regulations provided by the service provider. Now, in 5G scenario, everything is now converted into as per the user requirements. So it became the user-centric network. Now, how the concepts are again further enhanced, that is shown with the help of these two slides. Just see that there is a big coverage area, and in the center there is one tower which is actually transmitting, covering the whole the big circle coverage area. This is called the macro cell, within which there is a small deployment cell, that is a femto cell connected to internet and the core network. And core network has a backhaul connectivity with the tower. Also, there is a relay, which is the particular antenna or a kind of regenerator which extends the coverage area. So gradually everything is now converted into macro cell, micro cell, pico cell, femto cell kind of environment. This particular was there in LTE Advanced also, but these form the basis for 5G heterogeneous network also. There is a beauty of heterogeneous network that it can be divided into the hierarchical 2-tier, 3-tier network also. This is the typical heterogeneous network with macro, micro, pico, femto cells and the relay, that is the extension of the coverage area. So with these concepts, the architecture which is adopted for 5G is the heterogeneous architecture, what we are able to see in this particular slide. So this is about the deployment. This is about the inclusion of various types of the cellular sizes, the coverage area, deployment of the Wi-Fi or WiMAX or the other access point units or tower, relays, etc. So based on that, the different sizes of cells are created. Cell is nothing but the coverage area formed because of the deployment of the transmitter. Now, as far as the 5G terminologies are concerned, whatever terminology was started with GSM, like the GSM tower was known as base station. Then in UMTS, it was defined as node B. In 4G LTE, it was defined as E node B. Now in 5G technology, the same E node B is now known as G node B. It's the same thing, but we are interpreting in terms of 5G terminologies. So there is one slide show on the slide share about the 5G terminologies. You can go to that particular slide share and you can study the 5G terminologies or what enhancement we have done in case of the 5G terminologies. Even in case of ATRAN, See, in GSM scenario, it was known as radio access network or GSM radio access. In case of 3G, it was ATRAN. In case of LTE, it was E-ATRAN. Now, in case of 5G, it is known as G-ATRAN. So, whenever you refer the literature about 5G technologies, you may find this terminologies, and once you have the backward compatible devices and the idea about that, you can adopt it very easily. Now let us talk about the 5G vision. 5G vision is user centric. What user wants, accordingly you should provide the services. So whatever architecture we form, whatever protocol we develop, whatever scenario we create, it all depends upon the application requirements. So in general, there are 3 major applications which are identified in 5G. First is enhanced mobile broadband. See, we have the sufficiently high data rate so that we are able to see the video streaming at present. But people are not satisfied with this speed also, and they are expecting even more than this. So in 5G, the expectation is 1 to 2 Gbps bit rate and multi Gbps data rates. Means you can have the various possible data rates as per the multiple parallel transmissions. Uniformity, extreme capacity, and deep awareness. So as far as the mobile devices are concerned or the networking aspects are concerned, the fastest possible speed is expected in 5G. At present, the achievable speed is nearly 100 Mbps, but even more than that, we want from 5G. Second application requirement is mission critical services. They are all emergency services like automobile, self-driven automobile or accident identification, robotic control and robotic management, healthcare, telemedicine and emergency services in case of healthcare system. So these are all the mission critical services. That's what we are expecting from 5G. So it is a near real time scenario. So whatever protocol we have, whatever protocol we develop, it should be with minimum processing, minimum computations, and near real time solutions. So ultra low latency, high reliability, high availability, and the strong security. All these things are the second group of requirements. And the third group of requirements is the massive Internet of Things. Most of you might have heard the word IoT, Internet of Things. This is the biggest innovation in case of 5G scenario. Broadband we were using. So broadband services is not new to us. Even near real-time services were partially available. But IoT is totally a new concept what is included in 5G scenario. So of course, up to certain extent, it is included in 4G LTE advanced, but now we will find uncountable IoT devices on this earth. Low cost, ultra low energy, deep coverage, and high density of sensors deployment. These things are required in terms of smart cities, sensors for identifying the speeds and many other parameters which can be traceable, wearables like monitoring of health or heartbeat or pressure monitoring and control, smart homes, home automation, all these things you might have come across the various sensor based applications. Now the sensor based devices all non-alive devices will be supported with a SIM card, and they will be communicated directly on the basis of the logical IP address given to the devices. So these are all the user-centric requirements. Now we will see, okay, these requirements are further summarized over here. Massive Internet of Things, mission critical control, and enhanced mobile broadband. So the associated points are again summarized. This is actually the slide I have taken from Qualcomm. Qualcomm is doing lot of work in the development of 5G scenario. So deep coverage to reach the challenging locations, ultra low energy, so 10 plus years of battery life, ultra low complexity, so 10s of bits per second, and ultra high density, so 1 million nodes per kilometer square. These are all the massive IoT requirements. In case of enhanced mobile broadband, extreme capacity, that is 10 Gbps per kilometer square, extreme data rates, multi gigabits per second, deep awareness, that is a discovery and optimization. These are all the mobile broadband requirements. Extreme user mobility, ultra low latency, ultra high reliability, and strong security. So these are all the user-centric requirements. Now we have to modify our existing heterogeneous architecture in such a manner that we may able to satisfy all these requirements in a best possible manner. These are all Qualcomm slides, because the material provided by Qualcomm is very good to learn 5G scenario. As such, I have not used specific research papers over here. That's why I have not mentioned the references in my presentation. Most of the presentation is based on the figures provided by various companies like Qualcomm, Alcatel, and so on, Intel. So most of the things I have taken from the company websites. So this is all very authentic material. And of course, they are very lucrative, very live presentations in this particular images, so that you can have the good visualization of what is expected and how we can expect reach to our expectation. So here, this is the slide shows the enhancing mobile broadband services in terms of 3D or ultra high density video telepresence. Then demanding conditions like venues, say online matches or live matches or something, live events can be telecasted with very good quality and high speed, so that people can feel the telepresence for that particular event. And the tactile internet, broadband fiber to home for ultra low latency and ultra high density video streaming with much more capacity, so we can feel like virtual reality or presence in front of that particular video. So this is first requirement. Second is mission critical control services. As I mentioned, robots should be controlled, aviation control, energy, smart grid, medical, industrial automation, etc., autonomous vehicles. VANET is very important aspect in case of 5G scenario, because vehicular ad hoc, actually when we start with the vehicular ad hoc networks, we will find that you have to deal with dynamic channel. So everything related to static channel or channel modeling or whatever we do for normal mobile ad hoc network, everything will be converted into the dynamic scenario, fast changing topologies, dynamic channel, and many more. So there are so many challenges in the mission critical control services. So this is one more requirement. The third requirement is the massive IoT. As I mentioned earlier, power efficient, low complexity, and long range requirements are there for object tracking, smart city, wearables, smart homes, remote sensors or actuators, and utility metering. So now, when we want to this architecture on mobile or wireless basis, we need the spectrum, we need the frequencies, how to allocate these frequencies, what should be the basis. So actually there are three types of concepts which are adopted for 5G designs. Of course, this concept started in 4G LTE also, but now it is strongly applied in 5G scenario. First is license spectrum, that is the clear spectrum and exclusive use. Means the user who purchased the or the service provider who purchase the license spectrum and provide the dedicated services and take the bills accordingly, of course, then you can be considered as a primary user of this particular services. There is one more concept, that is shared license spectrum, shared exclusive use or complementary licensing. So when a particular spectrum is free, the secondary user can request and have the shared license for the time being, temporarily. And whenever the primary user requires that, secondary user has to free that particular spectrum. So there is a spectrum switching concept also, which is applied in 5G. And the third is the unlicensed spectrum, which is all known to you, Bluetooth, Wi-Fi, WiMAX, whatever ISM range frequencies we are using, they are all falling under the unlicensed spectrum. Now, this slide is also from Qualcomm, and it is very clearly identified that whatever user-centric services are there, based on the services, one should have the clear-cut distinction among the distribution of range of frequencies. One thing I would like to state over here, that for fifth generation systems, the spectrum which is proposed is called 5G NR. NR stands for New Radio Spectrum. So 5G NR starts from below 1 gigahertz or sub 1 gigahertz to 100 gigahertz. But at present, the millimeter wave services are restricted up to 30 gigahertz. So as far as the user-centric requirements are concerned, below 1 gigahertz, now below 1 gigahertz is also called sub 1 gigahertz. So these frequency ranges are making it possible to have longer ranges for massive Internet of Things. So these ranges are used for IoT applications majorly. 1 gigahertz to 6 gigahertz, they are wider bandwidths for enhanced mobile broadband and mission critical services. So these ranges are for critical applications. And above 6 gigahertz, of course, in 1 gigahertz to 6 gigahertz, few existing services are also used as it is. Means we are not throwing 2G GSM at all. We are not throwing 3G UMTS at all. We are not throwing 4G LTE at all. So these ranges are also falling between 1 gigahertz to 6 gigahertz. But above 6 gigahertz, there is a special development called millimeter wave. Millimeter wave communication is a key aspect of research in the present scenario, and these ranges will be responsible for extremely high mobile broadband services. So all these ranges are distributively applied from wide area macro to local hotspot deployments. Hotspots are the femtocells or picocells or femtocells, you can say. So it also supports the diverse network topologies like device to device connectivity or mesh networking or VANET or whatever type of network you want in your application. So spectrum distribution plays very important role along with the deployment or architecture part. From all above slides, previous slides, the resultant network which comes up, that is the heterogeneous architecture of 5G. It's very difficult to get complete figure on this particular architecture because it's too complex. It's like convergence of many services in one particular network. Here you will be able to see the various applications, the cloud part which is connected to the tower, line of sight connectivity. You can have the mobile small cell network, internet connectivity, cognitive radio network, Wi-Fi, gigabit Ethernet, massive MIMO network, and the internet management system with server, device to device communication, sensor network connected to internet that forms the basis of IoT. So, if you have the survey on the heterogeneous architecture of 5G on the net, you will find hundreds of different architectures covering the different aspects. It means we need all of them. You can see here the various types of links which are co-working rather. Wired link, massive MIMO links, wireless links, resource links, control plane link, user plane, communication link, etc. Control plane is the signaling aspects, user plane is the data transfer aspects, then the normal wireless links, massive MIMO links, etc. And here simultaneously the various acronyms are also listed out which you can go through. I will share my PPT with all the participants over here so that later on we can go through this particular figures. As I mentioned earlier, so many different services, so many different requirements and backward compatibilities. Of course, compatibility doesn't mean that the device can be used. Of course, you need a new 5G device, but it will support, the new 5G device will support the older systems like the circuit switch based call or 2G or 3G or 4G or Wi-Fi, WiMAX, Bluetooth, everything will be supported by 5G device. Of course, we need a new device for 5G. Our old devices cannot be used for 5G applications. So, as far as the deployment is concerned, the various sizes of cells are required to incorporate in the heterogeneous architecture. Now, gradually, let us move to the specific hierarchy which we are focusing. This is a typical architecture for 5G. As I told you, if you have the survey on the network architecture for 5G, you will find hundreds of different connection diagrams showing the different aspects of that particular network. So you can choose appropriate for requirement. Here I have selected this particular architecture specifically because later on our focus is going towards the software defined networking. So here one hierarchy is shown in which software defined network controller is part of the system which is connected to multiple routers and to the cloud system, and routers on its lower part is connected to the towers through the various gateways. There is one gateway, SAE gateway, which is very specifically used in 5G architecture. It's a system architecture evolution and uses eNode B and access gateway, and removes the radio network controller and SGSM. Plus MME support in that device, that is the mobility management entity. Actually from 4G advanced, this device is already started in use, and here partially the eNode Bs are shown, but eNode Bs can be replaced with G-Node Bs for 5G scenario. Then even the SDN controller is connected through ePDG, that is the Evolved Packet Data Gateway. Through ePDG, it is connected to the small cell deployments, various applications, various sensors, and so many things are shown at the lower hierarchy. And this infrastructure can be connected through firewall to the internet, the World Wide Web, or now it is Wireless World Wide Web, WWW. So this is typically IoT application servers plus IP multimedia subsystems and the connections for this kind of applications. So in short, I would like to develop or study the data transfer architecture of 5G. The networks from which it takes the data. This is actually the conceptual development of architecture of 5G. The radio access networks from which the data or the information or requests are taken up and delivered to the global part or the various applications. So the radio access networks include GSM, GPRS, AGE, UMTS, LTE, WiMAX, Wi-Fi, CDMA 2000, eVideo, CDMA1, IS95, ISP, etc. Means none of the older services are thrown. This inputs are passed through aggregator. Aggregators are the specific supports of the devices by which the information can be mapped into the required form, and thereafter it passes through the flatter IP network. Flatter IP network provides the IPv6 scenario directly without any hierarchy, and then it is given to the nano core. Nano core is actually the heart of the 5G architecture, where the billing services are also provided, and nano core is comprised of AIPN, nanotechnology, and the cloud computing. Cloud computing actually utilizes the internet and central remote servers to maintain data and the applications of the user. And the computations of nano core are then delivered to the various global applications or the concept providers like search engine or defense, scenario, astronomy, transportation, communication, medical and health, education, government, private portal, public portal, and the banking. So these kind of architecture is actually, this is actually the conceptual architecture of 5G, or you can say it's a functional architecture of 5G. So this way it works. The major development is the central part, aggregator, flat IP concept, and the nanocore concept. Detailing of all is a bit difficult over here, but at least with this reference, you can start the study in this particular direction. Almost all the devices are having the hardware with software support. So you can design the various algorithms to achieve the task provided in the central zone of this particular architecture. This particular architecture is also called a flat IP architecture. This is a generic architecture, and 5G uses flat IP concept so that different radio access networks can use the same single nanocore for communication. RANs supported by 5G architecture are, as I mentioned, all the older services. Flat IP architecture identified devices using symbolic names, unlike the hierarchical architecture. There is nothing like hierarchy or nothing like mapping. It's like direct dialing. So flat IP architecture is possible with the help of IPv6 scenario. And nanocore is the heart of the system. It consists of all IP architecture, cloud computing, and the nanotechnology. This is the detailed functional architecture of 5G for the control scenario. So there may be a terminal, a policy router, and a server. The various connections are shown over here. It is a bit difficult to describe in detail, but you may go through this particular scenario. The cross connections to the lower layer the cross connections between the lower layers, IP network layer, virtual network layer, and the application layer is shown over here, and how they are connected to the policy routers and to the server, and connections are at effectively at which particular layer, how the peer processes are connected to each other, that is shown over here. Now, any network architecture is not possible to run without the protocols. So the protocol architecture of 5G is also necessary to study. Here, in comparison with the OSI model, the whole protocol architecture of 5G is mapped. We know that OSI is a 7-layer model. So 7 layers are mapped into the equivalent 5G layers. You might be knowing the TCP/IP protocol also. TCP/IP protocol is a 4-layer structure. In the same way, this also forms the 4-layer structure, but in case of network layer, it is split into the small sub layers. So the layer wise comparison, if I say, data link and physical layer together forms the open wireless architecture, OWA. These particular layers will adopt most of the existing architectures, and these two layers will end up at the aggregator actually. Thereafter, the role of network layer starts. As I told you, lower and upper network layer architecture is required. Lower network layer and upper network layer protocols are required because we want to map everything into IPv6. We have adopted the flat IP architecture. That's why this is required. Session layer and transport layer combinedly is known as Open Transport Protocol, OTP. If we see the transport layer, actually it is very complex in case of wireless scenario. Just few years back, when we were dealing with computer networks, IPv4 based computer networks, it was very easy for us to have the crash recovery and all, because we had the fixed topology. But now we have to deal with dynamic topologies. So topology at one point of time will not remain so far. So crash recovery and many other, even the slow start and many other protocols are not possible. So you have to work with the different mobile TCP approach, where you have to go for split TCP and many other issues. So that's why we need the separate transport protocol which can handle this kind of issues. So it is OTP and application layer or the service layer. So the same thing what I described is represented in a better way. The lower network layers are connected to the upper network layer IPv6 address using the network address translation. Open wireless architecture, there is nothing specific because almost all the radio access networks are supported in this. Of course, a air interface is necessary to develop for 5G air interface because the conventional OFDM and other communication modulation techniques are not suitable. So, along with all existing RANs, the specific modulation techniques are also now uh, to be combined or to be developed, you can say. So these are all the various issues with the OTP and application layer services. Of course, the issues related to transport layer are well defined: quality of service, end-to-end delivery. Application services means any application, user-centric, of course. So that should be satisfied, etc. So difficult to describe each and every aspect over here. So now let us move directly to the software defined networking scenario. It is a new approach to the networking. We all know that when you deal with lower layers like physical layer and data link layer, the issues to be dealt with are physical transmission of frames, synchronous transmission, flow control, error control, then and point to point data transfer. Everything is to be dealt with at the lower layers. When we transmit the frames or packets from one end to other end, in between so many switches and routers may come up, which are actually responsible to make and break the connections. In which direction the packet is to be routed or forwarded, and whether it is a priority packet or not, what way, I mean, everywhere the decision making is done. So it's like a switch. If we try to replace this switch with an intelligent device, the whole concept is converted into the software defined networking. SDN is just the replacement of the switch. Of course, it is not a switch, but it is much more than a switch. You may achieve so many tasks. Even the switch, scheduler, controller, so many things combined in one particular device forms the basis for software-defined networking. So, software-defined networking is an evolutionary approach to the network design and functionality based on the ability to programmatically modify the behavior of the network devices. See, we have so many different options. We have many different bandwidths due to different modulation techniques. We have different types of applications like voice, video. We have the image, audio files, video files, simple file transfer, PDFs, PPTs. So many things are there. So if we are able to take the appropriate decision for allocated bandwidths, for allocated resources, or if we can take the intelligent decision for the type of packet, the priority packet, etc. Suppose we have two different routes. If one route is having the higher bandwidth, obviously the video packet should be transmitted through that particular route and vice versa. So this kind of decision making and scheduling is done appropriately, of course, with the programming, with the software support. Then we can have the very fast, intelligent solution. SDN users uses the user customizable and configurable software that is independent of hardware to expand data flow control. Even we are able to control the flow also. It will make the networks more flexible, dynamic, and cost efficient. while greatly simplifying the operational complexity. This is required because so many things are changing. We need a new network architecture because web applications and peer-to-peer processes are increased rather than simple emailing and simple file transfer protocol. There is a changing traffic pattern, rise of cloud services, consumerization of IT. IT consumerization is a very serious issue nowadays, and the big data means more bandwidth. So all these things are part of fifth generation scenario, and that's why we need the new approaches. And in that, SDN will give the very optimum solution, you can say. When the traditional computer networks are studied, they worked well earlier because we had no such issues. So data flow was controlled by switches, routers, and it was looking like this. And we had the critical distinction among the data forwarding plane with the packet streaming, control plane with the routing algorithms, and the management plane with the configuration based activities. So it was easily possible in the earlier cases. But now we have complexity that leads to the static nature, means highly complex scenarios, inconsistent policies, inability to scale, and the vendor dependence solutions are there. So we need something new. Software defined networking actually is an emerging network architecture, or rather it is a sub architecture, you can say. You can have the so many software defined networking supports in a very big network. You can have the campus wide control environment or one company wise control environment, something like that. You can incorporate the controller for that particular area, and you can optimize that particular area. So it is an emerging network architecture where network control plane is decoupled from the data forwarding plane, and it is directly programmable. Means you have to take the decision as an intermediate entity that whatever comes in, where it should be transferred, and how in how optimum way it should be transferred or routed in a particular direction, so that the best speed, best control, and the faster services can be available. SDN concept was led by Open Networking Foundation (ONF). SDN enabled control plane allows the underlying infrastructure to be abstracted. Means all existing systems like Wi-Fi, Bluetooth, everything can work with SDN. So as far as the data generation is concerned, there is no specific requirement. Only the thing is, when these packets are available, how to manage them. That is done with the help of software defined networking. So in short, the network appears, SDN network appears to the applications as a single logical switch entity, as I told you earlier. So this is the SDN architecture. Earlier I have shown SDN part in the 5G architecture. That smaller portion is enlarged over here, and in that we have three layers: infrastructure layer, control layer, and the application layer. So in the infrastructure layer, what we need to incorporate is the open flow switches. The software defined networking means the SDN control software is required, and it should be communicable to the business applications. So these are the major requirements. There something is required which can connect open flow switches and the SDN software. So southbound API like open flow controller is required. Many controllers are there which are specified or developed by the ONF, and appropriate one we can select. So in short, this particular is also the same SDN architecture represented in a different way. So it is actually again the infrastructure layer, control layer, and the application layer with API connectivities and the controller connectivity, but it represents the various capabilities required at each layer. So at the lower layer, abstraction capability is required. So it should decouple the hardware and software, control plane and forwarding, physical and logical configuration. Centralized intelligence requires the simplified provisioning, optimized performance, and the granular policy management. And the programmability requires enable innovation and differentiation, accelerate new features and services introduction, etc. So in short, in the SDN architecture, the control and data planes are decoupled, network intelligence and state centralized, and the underlying network infrastructure is abstracted from the application. So it's a 3-layer architecture, you can say. This is already described, so skipping this slide. There are 2 APIs. APIs makes it possible to implement the basic network functions like path computation, loop avoidance, routing, security, and many other tasks. So there are 2 APIs specified in the SDN architecture. Southbound API allows the controller to define the behavior of switches at the bottom of the architecture, and northbound API provides the network abstraction interface to the application and the management systems at the top of the architecture. For each of these tasks, the detailed code development can be done and the interfaces can be developed. Now, talking to the SDN controller specifically, which comes between the SDN switch and the SDN control part. The controller is the core of the SDN network. Just going back, the SDN controller comes between the control layer and the infrastructure layer. So, there are specific controllers available. In next slide, you will get it. By running the control plane as software, the controller facilitates the automated network management and makes it easier to integrate and administer the applications. SDN controllers uses the protocols like OpenFlow to configure the network devices. It manages the flow control to enable the intelligent networking. This is typical OpenFlow controller and its approach. OpenFlow is a protocol that is used. Now, of course, when you use any SDN controller dedicated to that particular controller, all the details you need to study and incorporate in practice. OpenFlow is a protocol that is used to define the communication interface between the control and the forwarding layer. It provides direct access to and manipulation of the forwarding plane of the network device, and it uses the concept of flows to identify the network traffic. This is the OpenFlow enabled switch. As I mentioned, below the controller, the switch comes in picture. So OpenFlow enabled switch architecture is shown over here. You can see in the diagram, OpenFlow protocol is connected to connecting 2 different parts, OpenFlow switch and the OpenFlow controller. So in the OpenFlow switch, we need, of course, to have the connectivity between the switch and the controller, we need one typical interface. In case of OpenFlow switch, we need the flow table and the group table to have the packet lookups and the forwarding scenario, we must have the secure channel and some pipelining process. So pipelining process, it maintains the sending of the packets between the flow tables by matching the flow entities. So there are two types of entities, open flow only and the open flow hybrid. Now here I am just giving you the highlight so that you can at least enter into the subject, because it just forms the visualization that what is the SDN. Detailing can be studied in your own way because lot many references are available. OpenFlow has its own packet header, its own format of creating the flow table. Various ports are there, standard, logical, and reserved. So if you study in detail the OpenFlow controller and the associated aspects, then how to implement it, that you can study very easily. Mininet, STNet, etc. are the software tools by which you can incorporate the open flow controller in your network. Inside the open flow controller, this kind of processes are created. When the packet arrives at the open flow switch, the header fields are compared to the flow table entries. Of course, some specific data is identified for the resource allocation, priority, or whatever. So at that particular level, the distribution of packet is handled optimally. If match is not found, the encapsulates packets and it sends to the controller back, and it drops or it makes a new entry in the flow table. If in the flow table the entry is found, then it is forwarded to the specified port or drop as per the situation at that moment. The various message types are controller to switch messages, asynchronous messages, symmetric messages, etc. So you can go through the particular SDN controller and the associated details. You will be able to. You can uh, just visualize the SDN like a smaller zone which you are controlling in your own way. Software defined networking is a smaller zone which you are controlling in your own way. It's like physical and application layer, physical and data link layer control directly accessible to the application. So the benefits, actually one or two slides are there. I'm about to complete. So let us quickly go through the benefits. It's a centralized control, reduce complexity through automation, higher rate innovation, increased network reliability and security can be achieved. These are a few SDN controllers which are available: Nox, Maestro, Floodlight, etc. And the few vendors who have produced open flow enabled network switches, they are also given over here: HP, Juniper Max Series, IBM Rack Switch, etc. Few more controllers are also available. Open Network Forum, so many clients are there. All the details are available in the net. And actually, the SDN creates the virtual network overlay approach concept. It creates the virtual network infrastructure for the underlying physical network. As I told you, it forms its own environment. You may have your own router, but if you can incorporate in parallel to that your own software defined networking also. So it's like an optimum intelligence switch which takes the optimum decision making to improve the network performance, to speed up the network performance, to use the bandwidth and spectrum efficiency very efficiently. Okay, so this is all about the network architecture of 5G and the software defined networking. Of course, I'm not able to cover so many things in detail because 1 hour is too less. It's a very, very big topic, but I tried my best to introduce the various aspects so that you can take up this work further very easily. Thank you so much. If any questions
Thank
are
you.
there, you can
Yes,
ask me.
yes, ma'am. From Rajendra Satvara,
Yes,
one question. What points should we keep in mind while designing 5G device?
5G device.
Yes, ma'am.
Actually, 5G device is the mobile unit which you are using. 5G device is the actually device means what I'm not understanding exactly, but there may be user equipment and there may be the different networking elements also like the gateways and many more things. So as far as the user equipment is concerned, it should be a device which should support all the older technologies plus the 5G incorporation, 5G support for high speed and millimeter wave support and many more aspects.
Okay,
So,
thank you, ma'am.
okay, I
And
think very difficult to answer this question because I don't understand about device, what device he is expecting, but it depends. Like gateway is to be designed, or router is to be designed, or controller part is to be designed. All are 5G devices. So as per requirement, their hardware and software part is specifically developed.
okay, thank you, ma'am. Another question from Darshna Jagiwala.
Yes.
What will be the scenario in 5G standard?
Pardon?
What will be the scenario in 5G standard?
Okay. Now actually there is nothing like 5G standard. 5G actually majorly developed or proposals are made by 3GPP. So just like GSM has its own set of specifications. UNTS has its own set of specifications. Similarly, 3GPP is actually providing the various standardization in form of releases. So the last release actually uh, specifies the set of protocols or the standards which is to be adopted for development of the 5G scenario. So release 13 onwards, most of the developments which are publicized by 3GPP, they are all related to 5G. 13, 14, 15, 16, 17. Release 13, 14, 15, 16, 17 mainly gives the idea about the 5G requirements. Still, there is nothing like standardization in case of 5G because it is a user-centric network. So we have to follow the detailing publicized in releases by 3GPP, and based on that we can develop the whole thing.
Okay,
Okay? Yeah.
okay, thank you, ma'am. One more question.
Yes.
What is the role of SDN in 5G? From
Uh, okay. Okay. As I mentioned, SDN is one intelligent addition. It is one intelligent decision making addition as a part of 5G infrastructure. Suppose you have to communicate. Uh, Suppose at home I have my own Wi-Fi network and I am communicating through that Wi-Fi access point to the outside world through the internet. Now, if my Wi-Fi packet directly moves with the existing infrastructure to the outside world, this is one thing. If I am part of the SDN controller and if my packet is routed through SDN controller to the outside world, it may be optimum transfer with the optimum resources, with the optimum speed, with the optimum decision making. So my packet in that case goes with some optimum decision making. It's a software defined networking part through which I am sending my data to the outside world. So this is the difference. This controller governs to optimize the transmission. Maybe in that way I can achieve the good speed. I may get the priority based services, or my packet may get the special response through the controller. So this is the role of SDN in 5G architecture. In both the ways, I am going to achieve the 5G communication. But without SDN, with SDN, there is a efficiency variations which we can have. So this is the role of SDN.
Okay, thank you, ma'am. And one question from Rajdeep C. Chavda.
Yes.
Can 5G spectrum harm
Hmm.
more than 4G in terms of waves and radiation?
Pardon? 4G
Means,
spectrum?
can 5G spectrum is harmful more than 4G spectrum?
Yes. In 4G, actually, we are not incorporating the millimeter waves at all. Millimeter waves are very short wavelength sounds, and if it is more exposed to the body. Now, you will be surprised to know that actually our body also restrict the millimeter waves. Our body acts as an obstacle because it absorbs the millimeter waves partially. And this is the biggest issue. So millimeter waves are normally used for tower to tower communication, or uh, when in most of the cases when the line of sight services are required, millimeter waves are used. So of course the higher range of spectrum is very much harmful to the body. All the
Okay, ma'am.
conventional frequencies are not that much harmful. Of course, the effect of radiation is there, but millimeter wave is really dangerous. But the deployment of tower and the use of millimeter wave is such that it's normal. I mean, the human body may not come in picture while communicating. It is just for high speed data transfer, either the millimeter wave communication or the fiber link. These two can work uh, for each other, like either these or that can be used for high speed data transfer.
Thank you so much, ma'am, for your valuable
Thank you.
time and giving us such an amazing information on 5G network architecture and SDN. It was a very useful and good experience which we all had throughout the session. I would like to thank our principal, Professor Jatin Vaidya, Academic Director Mahesh Bhatt, HOD Azhar Sheikh, and all faculty members of Parul Institute to provide motivation to take such a kind of initiative. Last but not least, I would like to thank our participants and huge amount of registration done for this webinar. And thank you so much, ma'am, for your valuable time. Thank you so much, ma'am.
Thank you. Thank you all participants, Unnati ma'am and others. Thank you so much.
You can leave, ma'am.
Yeah, yes.
Thank you so